So the other example we can have is, say, coefficient of friction. So we have an equation which says force of friction is equals to mu r. So this is force of friction. This is what we call coefficient of friction. And this is what we call reaction force. In specific, it is normal reaction force. It is not any reaction force, but normal reaction force. So similar question, we have to find the unit of the coefficient of friction. So coefficient of friction is given by mu, right? So we have to find the unit of mu. This color is not labels. Sorry. So find the unit of mu. So in order to find the unit of mu, we have to make mu as the subject of the equation. So force of friction divided by the normal reaction force. This is also a force. This is also a force. So we noticed, or we found that the unit of force is kilogram meters per second squared. That is divided by kilogram meters per second squared. So this is going to be 1. So what is this? We did not learn 1 as a fundamental unit, right? So if you go back, we did not learn 1 as a fundamental unit here. So what is this thing? So this is a unitless constant, right? So if we get 1 when we try to find the unit for constant or a unit or a quantity, and if we ended up with 1, then you should understand that quantity does not have a unit. So coefficient of friction doesn't have a unit. So earlier, so this is, we call this a coefficient, right? So this is a constant. It is also a constant, right? So this is a constant. So earlier also, we looked at a constant, which is gravitational constant, right? So the gravitational constant has a unit, and frictional coefficient of constant doesn't have a unit. So understand that constants could be of 2 types, right? So you could have unitless constant. You could have constants with units, right? So please make it as a note and understand this. Now we have gone through the unit conversions, understanding and finding the units. We have to now look at the conversion of units. So when we were looking at the units of mass, we said we have kilograms, we know we have grams, we have milligrams, we have tons, we can have micrograms, and there are so many other things. We can have megagrams, which we do not use in real world, but head up, right? So what are these? So we know these are alternate units. This is your SI units. So there should be a connection between these units, right? So kilogram should be converted to gram, kilogram should also be able to convert it to milligrams, tons should be able to be converted to grams, and you should be able to convert tons to microgram. So if you look at this, except the tons, right? Every other alternate units has this gram. So you have gram here, you have gram here, you have gram here and here. But we have one letter that is changing in front of the gram. So here we have kilo, we have milli, we have micro. So this is called kilo, we call milli, and we call it micro. So what are these? So these are what we call suffix, right? Suffix. So what are suffix? So we know that nowadays this is a fashion, right? So if it is 2024, people write it as 2K24, right? So this K is a suffix, which is kilo, which tells you it is of thousands or multiple of thousands. So suffix or suffix are those. So we have milli, we have micro, we have nano, we have pico, right? So milli is simple M, micro is mu, nano is simple N, pico is simple P. So what do they represent? So milli is 10 to the power of minus 3, micro is 10 to the power of minus 6. It is quite easier to remember. It is milli, micro, nano, pico, 10 to the power minus 3, minus 6, minus 9, and minus 12. Similarly, we have suffix for kilo, we have mega, we have giga, we also have tera, but don't worry about tera. Capital M, capital G, simple K. So kilo is 10 to the power of 3, mega is 10 to the power of 6, giga is 10 to the power of 9. So how do we now use this to find out what they are? So we will start off with easier example, which is kilogram. So we know that 1 kilogram is 1,000 grams. So let me write it like this. So we have 1 kilogram, which is equal to 1,000 grams. Or 1,000, so this 10 to the power 3 is basically 1,000, right? If it is 10 to the power of minus 3, it is 1 over 1,000. Understand that? So you can clearly see that I can write this 1,000 as 1 times 1, right? I can do that, right? So I can write this 1,000 as 1 times 1, 1,000. So I have this 1 here, right? I have this gram as well, but I do not have the kilo. Instead, I have the 1,000, which is right because kilo is 10 to the power of 3, which is 1,000. So instead of the kilo, we have introduced the 1,000. Does it make sense? So you just substitute whatever the suffix with the corresponding numbers. Let me give another example. So if I have like 1 microgram, I want to convert this to gram, right? So you have this 1 that will come as it is. What is micro? So micro is 10 to the power of minus 6. So you will substitute 10 to the power of minus 6. So 1 microgram is 10 to the power of minus 6 grams. Similarly, we can go ahead and find other values like, let's say 1 gigagram. I want it in grams. So you write the 1, you have the 1. Instead of giga, it is 10 to the power of 9. So 1 gigagram is 10 to the power of 9 grams. It is not only applicable for grams. I'm using grams because it is quite easier to relate. But if it is like 1 kilometers, I have to convert it to meters. It is 1 times 10 to the power of 3 because kilo is 10 to the power of 3. What if we have to go for 1 meters and I want to convert that to kilometers? Now what do we do? I do not know how to do this, right? Because there is no suffix here, there is no 1 here, there is no this thing, right? So in these cases, what we will do is we will substitute the suffix on the right side. So we have kilometers, perfect. I do not know what the value I'm going to get, but I'm pretty sure this is 1 times some value, right? So what I can do is I can divide this by k on both sides, right? So I can divide on both sides by k. So what I'm going to get is like on this side, I'm going to have 1 some value, meters. On the other side, it is meters divided by kilo. Kilo is 10 to the power of 3, right? Which is 1 meters. So 1 kilometers, my bad, 1 kilometers, right? So what do we get here? 0.001 meter is 1 kilometers. So let's do some examples, right? As we do some examples, you should get familiarized with. So I have 2.6 kilometers, which I want it in millimeters. So this is quite a different way. Like earlier, we looked at how to convert kilometers to meters. We looked at how to convert meters to kilometers. But here, it is quite different. We don't have meter here. So we are used to going from kilometers to meters, right? So let's do that. So what is 2.6 kilometers in meters? So we will have the 2.6 as it is. Kilo is 10 to the power of 3. So 2.6 kilometers is 2,600 meters. I want this in millimeters, right? So how am I going to do that? So it is 2,600 meter that I have to convert it into millimeters. So milli is 10 to the power of minus 3, right? So when I divide on this side, I would get 10 to the power of minus 3. So that would go up. So I would get 2,600 10 to the power of 3 as millimeters, right? Because 10 to the power of minus 3 is milli, right? So that is here, millimeters. So 2.6 kilometers is 2.6 times 10 to the power of 6 millimeters. So this is how you convert units, right? We will do some more examples on this, but for the time being, if you have any questions, please let me know.